Hello friends, good morning. Welcome to our chemistry class. How are you friends? Hope you are doing well. Okay friends, in this class I am gonna explain you about why back bonding leads to decrease in bond order. Okay, this concept I am going to explain in this class. Okay, before entering into the main concept, first let me tell you the main formula to find the bond order. Bond order is equal to number of electrons present in bonding molecular orbitals minus number of electrons present in anti-bonding molecular orbitals by 2. Okay, this is the formula to find the bond order. Okay, see, just let's think friends. See, whenever the number of electrons in bond order or bonding molecular orbital is more, okay, whenever the number of electrons present in bonding molecular orbital is more, then the bond order is more. Yeah, already we know that. Okay, whenever the number of electrons in anti-bonding molecular orbital is more, then what happens? Then the next means the incoming electrons enters into the anti-bonding molecular orbitals. Okay, see, whenever the number of electrons in the anti-bonding molecular orbital increases, then what happens? Gradually the bond order decreases. Yeah, let me tell you by taking an example. For example, see, let us take the carbonyl. Okay, see, we have the carbonyl. In carbonyl, the number of electrons present in the bonding molecular orbital are 6. Okay, and the number of electrons in the anti-bonding molecular orbitals are 0. So whenever we do the bond order for this, here we are gonna get a 3 as the bond order. Okay, okay, let us assume the second case. Okay, second case in the sense, see, whenever the number of electrons in the carbonyl increases, okay, whenever the number of electrons in the carbonyl increases, the incoming electrons to the carbonyl increases. So if the number of electrons are more than 6 in case of carbonyl, okay, listen, if the number of electrons in the carbonyl is more than 6, then the next electron, that means it may be a 7th electron or 8th electron, the next electron will enters into this anti-bonding molecular orbital. Assume that here the carbonyl has got 2 more electrons. So those electrons will enter into the anti-bonding molecular orbital. So see, now let us find the bond order for the carbonyl which is having 2 more electrons. So here the electrons present in the bonding molecular orbitals are same. So 6. And the number of electrons present in the anti-bonding molecular orbitals are 2. Okay, see, 6 minus 2, 4. 4 by 2, 2. See, here we got the bond order as 2. So here this, here this concept clearly indicates that whenever the number of electrons in the anti-bonding molecular orbital increases, okay, whenever the number of electrons in the anti-bonding molecular orbital increases, the bond order decreases. See, at first the bond order is 3, but whenever we are increasing the number of electrons, those electrons are entering into the anti-bonding molecular orbitals, so that here the bond order is reduced to 2. Okay, okay, see, we already know that here the carbonyl is a ligand, and the function of ligand is to donate electrons or the electron pairs to the metal. Okay, see, here the first what's happening is the ligand is donating its electron pair to the metal. Okay, whenever the ligand donates its electron pair to the metal, the electron density around the metal is getting increased. Okay, whenever the electron density on the metal is more, okay, it back donates. Okay, here back donates its electrons to the ligand. So this is called back bonding. Okay, this is called back bonding. See, if we observe here, due to back bonding, the number of electrons in the carbonyl is getting what? Increased. Okay, so we can simply say that back bonding leads to increase in number of electrons. Back bonding leads to increase in number of electrons in the ligand. So already I said, right, whenever the number of electrons, see, whenever the number of electrons in the ligand increases, okay, the electrons are entering into where? Antibonding molecular orbitals. So whenever the number of electrons are increasing, the electrons are entering into the antibonding molecular orbital, so that the bond order is getting decreased. So we can say that back bonding leads to what? Decrease in bond order. So this is a very important concept, friends. Okay, back bonding leads to decrease in bond order. So back bonding is inversely proportional to bond order. Okay, and already we know that, okay, bond order is directly proportional to bond strength. Okay, bond order is directly proportional to bond strength, and which is directly proportional to the carbonyl stretching frequency. Okay, carbonyl stretching frequency, and which is inversely proportional to bond length. We know, right? So bond order is inversely proportional to bond length, and this is inversely proportional to, see, whenever the frequency of the carbonyl is more, then the frequency of the metal and the carbon is less. Okay, this is the most important order, friends, which we had to remember. See, bond order is directly proportional to bond strength, and here we can add one more point. See, already I said, right? Yeah, that is back bonding. Okay, back bonding leads to what? Decrease in bond order. So back bonding leads to decrease in bond order. Bond order is directly proportional to bond strength. Bond strength is directly proportional to the frequency of carbonyl, and which is inversely proportional to the bond length, and that is inversely proportional to the metal carbonyl stretching frequency. Okay, this is most important thing, friends. Okay, let us take an example, friends. Yeah, in this we have to find the frequency. Okay, we have to find the frequency of carbonyl. Okay, frequency of carbonyl. Okay, friends, let us see. Here first we should know one concept, friends. Okay, if a particular metal has more oxidation state, means if the oxidation state is more, okay, oxidation state is more means what? It may be in plus sign. For example, if a metal has a +2 oxidation state, means what? It has already lost 2 electrons, so that it got a +2, like that. Means if oxidation state is more, means it has lost the electrons. That means its tendency to donate the electrons is less. That point we should know, friends. Okay, see, if oxidation state is more, means the electrons, okay, on that metal is less. If electrons on that particular metal is less, means what? Its ability to back donate electrons to the ligand is very less. That means what? Back bonding is less. Back bonding is less means bond order is more. Bond order more means what? The frequency of the carbonyl is more. Yeah, already I said this, right? Yeah. Okay, let us find this. See, here in this case the oxidation state is -2. Here the oxidation state is -1. Here the oxidation state is 0. Okay, yeah. See, here the oxidation state of chromium is 0. Okay, here the oxidation state of chromium is 0. See, here means what? Here the oxidation state is more, right? When compared to these two, here the oxidation state is more. Oxidation state state is more means what? Means here it can't give electrons to the carbonyl. Means here the metal is not able to give electrons to the carbonyl. Okay, see, whenever generally the ligand donates electrons to the metal, But here what I am telling is, if oxidation state is more on the metal, it can't donate electrons to the carbonyl. That means chances of back bonding is very less. Okay, chances of back bonding is very less. See here, assume this as back bonding. Okay, back bonding chances are here least, right? Yeah, least. But here see oxidation state is less, right? Oxidation state on the metal is somewhat less. So oxidation state less means what? See here it have some electrons, so of course it can donate, means it can back donate. Okay, it can do back bonding by donating the electrons to the carbonyl. Okay, so here the back bonding may occurs. So here the back bonding chances are okay high. I mean, when compared to the chromium, here the back bonding chances are high. But whenever we observe this titanium, its oxidation state is very less, right? -2. Okay, its oxidation state is very less. Oxidation state is very less means what? It has the more probability or the more tendency, or here the metal have more chances to back donate electrons to this carbonyl. So here the back bonding is very high. Okay, here the back bonding chances are very high. Okay, already we know that, means already I said, right? Yeah, back bonding. Okay, back bonding is inversely proportional to bond order, right? Yeah, back bonding is inversely proportional to band order. Why so? Why means, see, whenever the back bonding occurs, okay, electrons on metal, okay, see, whenever the back bonding occurs, electrons on metal decreases. How the electrons on the metal is getting decreasing means, here the metal is donating its electrons to the ligand. Okay, already I explained this, right, by taking the example of carbonyl. So due to back bonding, the number of electrons in the anti-bonding molecular orbital increasing. Okay, whenever the number of electrons in the anti-bonding molecular orbital increases, the bond order decreases. Okay, so already we know the relation, right? Yeah, bond order is directly proportional to bond strength, which is directly proportional to the frequency of the carbonyl. Okay, yeah, see here this is the back bonding. Okay, see here the back bonding is least, right? So back bonding least means what? Back bonding is inversely proportional to what? See, back bonding is inversely proportional to bond order, right? So here the back bonding is least means what? Bond order is high. Bond order is high means what? The frequency is more. So here this is the order of the frequency of the I mean, here this is the stretching frequency of the carbonyl. Hope you understood this concept, friends. If you have any doubts, please comment. I'll try to explain. Thank you, friends.